And from electromagnetic theory. This is from the waveguide portion of electromagnetic theory. A waveguide consists of two infinite parallel plates, perfectly connected to separation of 10 raised to power minus 4 centimeter with air as a direct. Assume that the speed of light is 3 10 raised to power 8 meter per second. To determine the frequencies of TM wave which can propagate in this waveguide. Okay, so there can be multiple options which can be correct for this question. Now, it's a simple question. We just need to know for a parallel plane waveguide, the cutoff frequency FC is MC upon 2A, right? And if I want to find the minimum frequency or the mode, the lowest mode, then it will be TM1 mode. This implies M equal to 1. Race will be higher mode of this. So here if I put M equal to 1, I'll get FC is equal to C upon 2. Okay. So this becomes the lower cutoff frequency. Any frequency greater than this will propagate in the waveguide. Let us see the value of this. So this is 3 into 10 raised to power 8 upon 2 into 10 raised to power minus 4 into 10 raised to power minus 2. Okay. So this will become 1.5 into 10 raised to power 16. Right? 10 raised to power minus 4 centimeter. So that is going to become 1.5 10 raised to power 40. Any frequency greater than this will propagate. Now let us see this. This is lesser than this value, it will not propagate. This is greater than this, it will propagate. This is lesser than this, and it will greater than this. So answer for this is option A and C. Okay, simple question. We just need to understand this expression. Right? And since I should put the lowest mode because other higher modes will have further higher cutoff frequencies. So that mode is not mentioned. So TM wave is mentioned. So the lowest mode corresponding to M equal to 1. The answer is option A and C. That's the end of question from electromagnetic theory. Question from electromagnetic theory, the electromagnetic field portion. Now in this question, we need to find out the total charge which is enclosed, electric charge enclosed within the cubical region R. Okay. So the displacement density vector is given. And we know that the divergence of the displacement vector density will give you the charge density, volume charge density, and the integral of displacement divergence of the electric displacement over the volume will give me the total charge. Okay, so the Maxwell's equations will come into picture. So let us see this. The electrostatic field, in electrostatic field, the electric displacement density vector D is given by this expression. And unit vectors along x, y, and z respectively. Consider a cubical region centered at origin with each side of length 1 meter and vertical height plus minus 0.5. Okay, so it's a cube. The electric charge enclosed within R is how much? So we know that del divergence of displacement density is going to be rho v, right? And if I integrate rho v over volume, I'm going to get the total charge enclosed. This implies total charge enclosed Q is equal to del dot D dV. So this is the expression. Now we have to find the divergence of D. So let us see what is del dot D. So del dot D is nothing but the divergence of this, so that is going to become 3x square. That will be a scalar quantity plus 3y square plus 0. Okay. It is del over del x, okay, plus del over del y, okay, plus del over del z, k cap, dot product of this with x cube I cap plus y cube j cap plus xy square k cap. Okay, so we'll get this expression. Substitute this over here. We get q, which is 3x square plus 3y square. Now here the Cartesian coordinates dv is going to be dx, dy, dz. So one by one we can take this. X cube, I write integration minus 0.5 to 0.5. This will become y z. This is y minus 0.5 to 0.5 z 0.5 to 0.5. Let's next up. This will be y cube minus 0.5 to 0.5 plus x minus 0.5 to 0.5 and y is minus 0.z. Minus 0.5 to 0.5. Let us solve this. So this will get 2 times, because the both expressions are similar, and this, so I can write this 2 times. So going to become 0.125 minus 0.125. Next is 0.5 minus 0.5. Next is 0.5 minus 0.5. That is going to become 1 into 1 to 2.5 to 0.52. So that is the charge. Okay. The answer for this is 0.5. So only thing that we need to understand is this expression, which is divergence of D gives me the volume charge density, and integral of the volume charge density would give me the total charge. Be careful while calculating divergence and this integral, because here the chances are there where we can make a mistake. Okay. So it's a simple problem. The answer is 0.5. That's the end of question form EMCQ.